Hello, everyone. The title of the talk is Understanding and Adopting Research in Quantization, a Concise Guide. Speaker, Mrinal Kanti Roy Choudhury. Today is June 14, 2025. An introduction about quantization. Quantization refers to the process of transforming a continuous analog signal into a digital signal with k discrete levels, or simplifying a digital signal from n levels down to k levels, where k is smaller than n. This essential technique forms the foundation for representing, processing, storing, and transmitting analog data in digital systems and plays a vital role in efficient data compression. As a key problem in source coding and information theory, quantization remains an active and evolving field of research with diverse applications across engineering, technology, data compression, and clustering. Classification of quantization. Recently, two new approaches, constrained quantization and conditional quantization, have been introduced. With the development of constrained quantization and then conditional quantization, the quantization theory has branched into two main categories, each with two subcategories. The two main categories are constrained quantization and unconstrained quantization. Unconstrained quantization traditionally in the literature is known as quantization. Again, constrained quantization has two subcategories, conditional constrained quantization and unconditional constrained quantization. Likewise, unconstrained quantization has two subcategories, conditional unconstrained quantization and unconditional unconstrained quantization. The introduction of these two new frameworks, constrained quantization and conditional quantization, has significantly deepened and expanded the scope of quantization theory, opening up a wide array of practical applications in real-world scenarios. A concise guide. As a concise guide to understanding and adopting research in quantization theory, the following three papers serve as valuable references, all written by Pandey and Roy Choudhury. The paper one is Constrained Quantization for Probability Distributions. This is to appear Journal of Fractal Geometry. In this paper, that's in paper one, there are many basic results are defined and also have been proved with many interesting examples. In the second paper, that is in paper 2, conditional constraint quantization, conditional constraint and constraint quantization for probability distributions. In this paper, conditional quantization has been introduced. And there are also many interesting results and proofs are given with many examples. The paper 3 is Constraint Quantization for the Cantor Distribution, which is published in Journal of Fractal Geometry. In this paper, that's in paper 3, the definition of constraint quantization, which was defined in paper 1, has been generalized. And also, some interesting results are given on Cantor distribution using constraint quantization. Remark. Since unconstrained quantization is a special case of constrained quantization, the above three papers will also facilitate a quick understanding and adoption of research on unconstrained quantization, which is traditionally known as quantization. Thank you.